Hello everybody, ciao a tutti, benvenuti a questo evento dell'Italian Spring User Group. Il talk sarà in inglese perché quest'oggi abbiamo degli ospiti internazionali. Del Spring Boot Framework team and Micrometer Spring. So now we will talk in English because the talk is in English, of course, and we are Italian Spring User Group, and you can see the VMware logo because VMware is our main sponsor, and we are really happy to have it in our meetups. We are ItalianCoders, and we have many channels, and we have a Discord server to talk about technology and many topics. We have also a YouTube channel, and the live will be present and will remain also in the channel. So today we have two great developers, Spring committer and a member of Spring Framework team, Brian and Stéphane. Bonsoir, bienvenue.
Hello.
Sorry for my little French. Fortunately, today we will speak in English, so we are really happy to have you here today. Thanks to be here. And how are you, Brian?
I'm good, thanks. I'm happy to be here. It's been it's good to.
And you, Stéphane?
I'm good, thank you.
Okay. So I don't hesitate more. I'm really happy to attend at this great talk. The stage is yours. You can share your screen, of course.
I think I already am.
Yeah. Okay, perfect. Perfect.
All right.
Okay, the stage is yours. Enjoy, and I remember to post your question in a comment. At the end of the talk, we have a Q&A time, so we try to answer at all your questions about this topic, of course. Enjoy.
Thank you. Hello, everybody, and welcome to this talk, Efficient Web Apps with Spring Boot. I'm Brian, Stéphane. So today we will start with a demo app, and we will show a few things with mostly live coding, but we will start with a few slides first to just explain a bit the background. So during this talk, what we'll try to answer a few of those questions, including like, is RestTemplate about to be removed? You probably heard about things that we've done in Spring Framework 5 about it. Other questions like, how can I keep an eye on the behavior of my app? How can I know what's going on with my app? And other things like, how can I manage concurrent calls to remote APIs? It's really hard to do with RestTemplate, so it's a really hard problem to achieve. And same other questions like, how can I investigate latency issues? And if you're probably getting the hint that we're throwing here, you probably wonder, do I really need to learn about Webflux and Reactor because it's really frightening? We'll try to answer all of them, and you'll see during that talk how we can do that.
So the example that we are going to use today is based on Spring.io. What we want to do is we want to build a small application that gets information about the projects that are being generated in the Spring Boot version that users pick. So if we look at Spring.io as a web application, there is a service behind the scene that actually can be used by many other clients. So you could use that from the command line, from your IDE, from the website itself, of course. And there's an API you can call to generate a project. We store data in an index, so your preferences and the options that you've chosen. And what we're going to do is build this app that basically show some graph based on the data on the index. It's for the purpose of the talk today. It's all fake data, of course, but we'll see how that's relevant. So to build a graph, let's assume that we have 3 services that we have to call, and we're not really responsible for those services. So there isn't a fixed contract, and we'll have to deal with it, which is, I'm sure, a situation you've encountered before. So we have the projects themselves, of course, which will show the trend. There is an agenda API where we can add events on top of the timeline, just maybe to correlate the fact that there's less projects being generated or more projects being generated at a particular time, and then see there's actually an event that day, and that might explain why. We also want to look for people that may be abusing the service. So we have an API that gives us the list of top IPs using the service, and because we prefer to see a host name rather than an IP, we also have a resolution service that will transform the IP into a name. And unfortunately, that service only accepts one IP at a time, so it's a bit annoying. But again, this is a constraint, and we'll try to build our app so that it's the most efficient and the most resilient. All right, that was about it. So let's start coding.
So right now we're in Stéphane's IDE. You can see the dashboard application. That's the application we are working on. The generator one is basically shipping the 3 pieces that you saw in the previous slide, where we had all the external APIs. So we won't really take a look at generator. Generator is just out there. It's not in our control. The dashboard we're working on. But Stephane will show you that the generator app is working already on port 8081. And we can see examples of the API results that we're getting if you're calling the API. So you can get the number of projects created by day and so on. And here you can check out the events, so the calendar, what happens during a certain period. So we can see that one day there was a Slack outage, and there can be here this very conference. So this is a way to correlate things and see on graph. And the third one is the top IPs. So that's the list of IPs that are mostly using the service. And the last one is the reverse lookup API. So you send it one IP, and it will send you back the domain name, which is associated with the IP. So like a reverse lookup. So that one is, everything here is totally fake, all the IPs, all the entries, but this is what our dashboard application has to deal with. So let's take a look at our dashboard application, which is on port 8080. We already have something running. As you can see, when you load the application, you see a unified graph with the number of projects created by Spring Boot generations, 24x, 23x, 25x, and as well the events that are populated on the graph, because you want to know, oh, why do we have more projects being created on that day, or is there something going on? So we're trying to have that. And as well, we can see right below, we can see the top IPs that called our service for creating projects, including the result host name for each IP. So for that page, you basically need like one call for the projects, another call for the event, one call for the top IPs, and a bunch of calls to get the reverse IP for each IPs. So that's a bunch of calls. And that's what Stephane right now is showing. So in our dashboard application, we are shipping all that information into a stats container object. And that stats container, we need to fill it in with information. So we're fetching the statistics, so the projects, the number of projects created. Then we're getting the events out of the API. Then we're getting the clients, the list of IPs. And then for each client in that list, we are fetching the reverse IP. We're getting another list, and we're shoving all of that into a single stats container object that contains all of it. And with that object, we can render our main view and have everything. But to get that information, as you're probably guessing, we are basically using the RestTemplate from Spring to call our remote service, which is here on port 8081. We're fetching all that data and we're assembling it into the stats container object. So you can see all the web URIs to get the data. So it's pretty simple. It's nothing fancy, but we're getting a lot of calls and we're getting a lot of data into a single object to have our view. And that's basically the use case behind our application.
So one way to start improving the situation would be to use some of the reactive features that have been introduced with Spring Framework 5 and that you can enjoy with the Spring Boot 2. If you're not aware, Spring Framework now has two ways of building a web application. You can build a web application the usual way using Spring MVC and Tomcat and the servlet stack. So basically the environment that we've known for many years. You can also use something called Spring Webflux, which is an alternative that you can use on top of a reactive stack, and you can deploy such applications to Tomcat, Jetty, and Undertow as usual, but you can also deploy such apps to Netty if you want to. So we've been talking a lot about those two options, and there is not one that will replace the other, so we're not going to, for instance, deprecate Spring MVC and force you to rewrite all your apps to Webflux. That's definitely not the goal. But what we want to show you today is how you can use some of those reactive features in your existing app. So how you can use some features in an MVC-based app. And the main feature that comes to mind when talking about this is using the new reactive web client. So you've seen initially Brian mentioning that is the RestTemplate going away? Is it going to be deprecated? Maybe, Brian, that would be a good time to talk about that.
Yeah, so initially when we rolled out Spring Framework 5, we might have communicated a bit strongly that that RestTemplate was that we were close to deprecating it. We're not deprecating it per se, so you're safe. You can keep using it, no problem. It's just that these days applications are more distributed. They need to do more calls like that, to more remote calls. They need to deal with more modern web usage, like streaming use cases and so on, and they need to be really efficient. And RestTemplate is not really built that way. It's been built with something in mind where you just had one request and one response, and you got the full body at a time. So we can't really evolve the RestTemplate without breaking the contract. So we created instead the web client, which is of course returning reactor types, but we think that you can really use it in a really regular MVC application and still get very good mileage out of it, especially in a case like this. So we'll see how you can use that in that client into this application. But if you're fine with RestTemplate right now, you can keep using it, no problem.
All right, so let's give this a try. To bring those reactive features, I'm going to add Webflux to this project. And as you can see, you have a certain infrastructure with Spring Boot. So there is a RestTemplate builder that Spring Boot has auto-configured for you, and it has a bunch of settings such as Jackson options or whatever customizations you may have applied to your app. And the idea here is to provide you the same developer experience. So if you want to migrate to the web client, we also offer a builder for the web client. So let's change that to web client here. And you'll see that the API is slightly different, but you'll find your way pretty easily. So one main difference is that rather than returning the data when you invoke an operation, it's going to return you a publisher to the data. And Brian, while I'm writing the code, maybe you could describe a bit what that means in practice.
Yeah, so web client is shipping, you can return out of it the two main types from Reactor, which are mono and flux. So mono is kind of like a completable feature or a feature, but it's really reactive in the sense that there's the back pressure support and all the reactive streams spec behind it. So, but you get basically one element. So in this case, we are fetching one generation statistics object, and we will get it in a lazy, asynchronous, non-blocking manner with mono. As when you get a list, you can instead get a flux. So instead of getting a mono of list, which is not really elegant, and you'll see why it's not really helping in our case, we'd rather be using a flux. So a flux can be used as an asynchronous list somehow, but you can also see it as really a flow of events. So you might get them one by one or a bunch of them. It's really useful, especially just like Java streams, basically. But in this case, reactive. So we will turn that's what Stephane is doing. We can turn the API usage with WebClient. It's quite similar to RestTemplate, so in the sense that you have URI templates, and here, instead of doing post for object or something, we will call retrieve, and we can type the body to a flux or a mono and give it the type that we want. So it's not that different. It's just the return type that is different here in this case, but we're getting the same results. So here, what we could do is calling block. So this won't really, we've got it working. So if you do that, it will work, and the API, the application will keep working. But of course, like you probably think, we are not really improving things in the sense that we're still blocking at each step of the processing of the request. So we're fetching the statistics, we're waiting to get them, then we're fetching the events, then waiting to get them, and so on. So we're not really making things more parallel. It's not really helping, but we can see at least that it works. So with just a few changes, we can see that the application is still working, that we're still getting the graphs, and that is still working as expected.
Yeah, but as Brian mentioned, we haven't really gained anything. So once you have the infrastructure in place where those calls are represented as a publisher, so either as a mono or as a flux, as Brian explained, we can now go further and basically keep composing the data in that chain. So taking the data and transforming the data in a reactive fashion higher in the stack, if you will. So one way to do this is, rather than returning a stats container here, which is definitely a blocking call, we could return a publisher of the stats container, and let Reactor, so that's the engine behind it, figure out how make those calls in the most efficient manner. So let's give this a try. You've seen here that we have a list of events because we've used collect list, which is an operator in Reactor. But let's move those and remove the blocking statements. So this is giving me a mono now. For the events, I'm not really interested by getting a notification every time I receive an event. So when we parse the JSON and we parse an element one by one, I'm not interested to get a callback for every event, because at the end of the day, the only thing that I need is the list to build a container anyway. So to materialize that, I could ask for a single event, but the body of the data is actually the list. So we're removing the list here. And finally, same thing for my reverse lookup descriptor. It's called that top clients. I'm going to start transforming the data. So I need to write a new method that will compose the other calls that we have below.
Yeah, so right now, as you can see, with the blocking fashion, we're trying to use Java streams and parallel stream to try and parallelize things. Once we're getting the list of IPs, we're trying to do some scatter, gather mechanism to get the reverse lookups. So we can do that naturally. That scatter gather scenario is it can be done naturally with Reactor. In the case that, so here we're getting a flux, so a list of all the client IPs, of the client IPs that are calling our service, and from each of them we need to do an asynchronous call, another one. This is why we're using FlatMap. So FlatMap is a way to nest asynchronous calls inside each other and flatten the mono of mono, or the asynchronous of asynchronous fashion. So here, for each of those clients, we're doing the lookup for the IP, and then in the end we're getting a flux of the reverse lookups from that. So the scatter gather mechanism is done with one operator here. And in the end, we are still collecting the list. The collect list is an operator that basically waits for all the elements, buffers all the elements, and then returns the list. In our case, it's not like we're doing streaming. We're just getting the whole thing from a single document, JSON document. So it's not like we're waiting forever. It's just parsing.
So now we need basically to tell, these are the 3 things that I need to build this container. I don't care how, but invoke that in the most efficient manner and give me a callback once you have the data. And there is an operator for that called zip. So you can zip a number of publishers, and it will give you a callback with a tuple as an argument. So we're going to say subscribe to these, and let me know when you have it. And when we are within this this callback, it's basically your code when you get the data.
So in this case, when we're doing monozip, we're letting Reactor subscribe and trigger all the 3 code paths above. So fetching all the data at the same time. And as soon as all 3 are there, we are merging all the data into our stats container. So we're making progress here, because instead of doing calls sequentially, we're making them in parallel. So we are much better with processing time on the server, and the response times for the clients should be way better.
So how do you get the data? So you get a tuple there, and based on the number of arguments that you specify, you get a specific implementation with the same number of arguments. So T1 is the first argument, T2 is the second, etc., etc.
Because we're dealing with a functional API, it can seem a bit strange at first, using those tuples and chaining all the time. If you're familiar with the JavaStream API, it's really it doesn't look that bad. But at first, it takes a bit of time to try and think in a functional way. But in cases like this, where if you would have to do that in an imperative way, it'd be much harder, because you'd have to deal with concurrency exceptions. One of those calls failed. How do I manage errors handling and so on? In this case, everything flows through the same pipeline, so you can deal with errors and much more. And we'll see that later. You can do that in a single way, which is much easier, and you don't have to care about concurrency programming and so on.
So we've used those features a bit higher in the stack. So now we basically need to block at some point so that something actually subscribe to it. So there's actually two usage of this method at the moment. There is our controller, of course, which is here. That's really the main entry point. So I'm going to block here so that actually we subscribe at really at the highest possible point for this kind of application. I also have a problem because I have a test that's using this API, and I need to update that to return a publisher. So if you want to create a publisher in a test, it's really easy. There is an operator for that. So if you have the data at hand, you can just use the just operator, and you'll get that. Don't worry about the code. And by the way, I don't think we mentioned it yet, but
yeah,
we'll share with you the GitHub repository. And it has one commit per demo, so you can look at the commits and see what we did at your own pace. All right, so we're basically back with the application as it was, and it's restarting now. There we go. It's still the same as before, right? You didn't really notice anything because it's running on everything is running on the same box, so it's really fast, and there is no real problem. So the fact that it's going asynchronous doesn't make any difference. But let's change that.
Yeah, so like Stéphane's saying, when everything's local, you don't have latency, you don't really see a difference. But here, what we're actually trying to do is we have an actuator custom endpoint on our generator application, the one that ships all the APIs that we're using in our dashboard. And this specific endpoint, with that endpoint, you can tweak the latency of the calls, of the response calls. So right now, we've got max and mins, but the ratio is 0%. So we've got 0% latency, best case scenario for all the calls made to our generator app. And right now, Stephane has set that to 80%. So you've got a 80% chance to have a high latency when you make a call to one of the APIs that we are using. So we don't know which one yet. We're just setting one thing here. I guess Stephane is gone.
I think he's gone. Yeah.
Yeah.
So
that's a hard crash.
No.
In the meantime, I will answer questions. No, you're back.
Okay.
You know what I did? I want
Command W.
No, I wanted to refresh the app.
The wrong window.
And I refreshed the one with the streaming.
Okay.
Yeah. Sorry about that.
Don't worry.
So now that we've refreshed the right, I've refreshed the right page, you can see now that it's really slow. You can see, oh, there you go. It shows something. So this latency endpoint that Brian was mentioning, we don't know which one it is. But we've created a problem, and now let's figure out where this is coming from. How do we spot that kind of stuff, right? Because if we go to the Earth endpoint for the application, it's saying it's healthy. And if we look at our backend, it's healthy, no problem. Okay, so maybe that was a fluke. No, it's still slow. So
yeah,
how do we find out about that stuff?
There are two problems here. The first one is if you're using actuator health endpoints for like the general state of your app, it's rather incomplete. You're just getting a view of the dependencies and if something's broken, but you don't get, like for the user, the end user, it's definitely broken. You don't get an acceptable response time. For the actuator, everything is fine. So that's one problem. And the other problem is the problem that we're seeing here could be much worse if we were using RestTemplate, because if all the REST calls are done in sequentially, then you'd bet that you'd be paying the latency price, like the top price for that latency. Here we're paralyzing things a bit, so we're still paying it, but maybe not as hard as we could. So we'd like to know which call, what API is responsible for that problem, and how we can solve that problem. So that's why we need some kind of tool that is better than actuator health endpoints. We need something else, something that is measuring all that.
The Spring Boot does have support for observability, and as a Spring Boot 2, the metrics part of the observability story is implemented with a library called Micrometer, and you can think of Micrometer as SLF4j, but for metrics. So it basically provides an abstraction, an API, where you can define your metrics and instrument your components in your application. And it will provide what they call a registry, which will map those to the monitoring library implementation specific details. So Micrometer has support for a bunch of libraries, like you can push data to Prometheus, Datadog, Atlas, StatD, Wavefront. So there's really a lot of implementation that are available to you. And your code doesn't change, so really the implementation specific details are abstracted to you. Spring Boot also has a number of auto configuration for those instrumentations. So if you have a Spring Boot application, it will automatically, once you use that feature, it will automatically emit a number of metrics based on the JVM, the application. If you're using a web application, it will also emit some metrics about web traffic, etc., etc. So let's see that in action with Tanzu Observability. So we are going to use one of the possible options, and that's Wavefront. So let's have a look at that. I'm going to add an extra starter to my app. This is the one. And this is a SaaS-based solution, and Wavefront has an explicit Spring Boot integration, and it will offer you access to a freemium cluster. So basically, if you don't do anything and you add this dependency, it will auto-negotiate an API token for you. It will save it to your home directory, and you'll be able to emit metrics to the freemium cluster and basically try what Wavefront can do for you. So that's what we are going to do now. I need to restart the app first because there's a new dependency.
So right now in the logs, you should be seeing what Stéphane was talking about, which is the application starting and a token being created for you in your app. Or in your case, you probably have a token already present in your home directory, so it's using an existing one.
Yeah.
So call, crash, refresh. We don't know.
Maybe refresh.
I'm sorry. I won't say it won't happen again because it's if you're in the wrong window, it's very easy for you to. And I have to control refresh all the time. So probably I should do this. Yeah. Just to make sure I'm not doing it.
We are live. It happened.
Sorry about that.
Oh,
right. So the application is still slow, right?
Yeah.
It doesn't change. Still problematic.
Refresh.
So if we look at the app, we can see that indeed, as Brian was mentioning, I already had an account, so it did not create an account for me. But if you try this on your machine, you'll get a different message the first time. It will tell you an account has been created for you, and these are the details. So right now you can see my API token. I'll have to blank that at some point. But also to be able to access the data, you're offered a one-time use link. So it's basically a link that you can use to access your dashboards. And if you share that with a colleague and they try to use it, the link won't work. So it only works the first time. So every time you start the app, you'll get that link and you'll be able to access to your data. And once you're on the dashboard, you can also invite yourself. So you can create an account and then forget about that link and just use the credentials that you've specified. But you don't have to, right? You can use that without registering.
So yeah, there are many other projects that are supported with Spring Boot for observability. We're using here Wavefront because it's really easy to set up and it's really easy to use in the demo. And you'll see that we've got like quite a lot of nice graphs with a default experience. What we can do also...
Yeah, I forgot to do something first because you can monitor many applications with the same account, right? You can have an overview of all your apps. You need to tell, otherwise you'll get a default value. You need to tell the name of the application, so the group of service, basically. Let's initialize that. And then the service, we call that the dashboard. So that will be, the metrics will be tagged as the dashboard of the initializer stat service. What we also want to do is making sure that we push metrics more often, because it's a demo and you don't want to wait 1 minute to see what happened in the last minute. So I just changed that to use 50 seconds rather than 1 minute. 1 minute is the default, so it will emit metrics every minute to the backend.
Just so you know, we're seeing all your questions. We'll answer all of them. They're all really good. So we'll use the Q&A section if some of them might be answered during the rest of the talk, but keep asking. They're really great. We'll answer them.
All right, so it's still really, really bad, right? It's still very slow. Let's go back here and look at what we have. So if you open that, you'll be presented, because we know this is a Spring Boot application, you'll get a dashboard with some of the metrics that Spring Boot offer out of the box. So you don't have to do anything, and you'll be presented with this dashboard. So you can see that it's coming from my machine. The application is the one that I've defined, and this is the application. So we can basically monitor our app, and we can see, by the way, that the slowest request, that won't come as a surprise, is the main one. Remember the one in the controller where I invoked block? That's obviously the one that's the slowest, but that doesn't tell us much. Let me change that also to...
Yeah, last 2 hours.
Yeah.
Better.
So there you go. You can see that it's almost 8 seconds, right? That rings a bell. 8 seconds was the max latency time in our tool. It doesn't go further because this is whatever is happening on the back end, since it's happening asynchronously and in parallel. That's the slowest request that basically trumps everything.
We already have quite a lot, like the errors, the latency, GC, everything you need, everything that you can get out of the box with your application, with a Spring Boot application. You can already get quite a lot, not just about the JVM, but as well as the Spring Boot applications and all the instrumentation that we're already taking care of. But in our case, we'd like to know more, especially around the client, because that's where that we think there's the problem. One of those calls might be guilty of slow response times, but we don't have a graph for that right now.
Okay, so let's build one. So you go to dashboard here, create chart. Then you're presented with an empty chart, and then it's very, very easy to go ahead and build your own. So in data, I'm going to select metrics. Then I can see all the metrics that have been pushed for this particular backend. HTTP, we've already seen some of the server-side metrics in the dashboard, but as Brian mentioned, we're more interested by the client. So let's take the max time for client request. And we have some data here, so let's change the scale to 10 minutes again. We can add more filters over here if we wanted to. But we can see that...
Someone is asking about zooming. Can you...
Oh, I can...
Is it working if you try to zoom?
Try to zoom, yes.
Cool, thanks.
So we can see that the slow request, 7.3 seconds here, which is the max, it's our damn free resolver, right? It's free, so obviously something must go wrong. It's not always the case for everything, hopefully. But now we've really easily identified the problem.
Yeah, and just so you know, because we didn't talk about this, we are getting metrics for the web client here because in a Spring Boot application, if you're using the RestTemplate builder for RestTemplate or the web client builder, if you're using the facilities or infrastructure that Spring Boot is providing you for any component, chances are we've already built the instrumentation for it. So it means that if you've got a micrometer set up with your application, we are already instrumenting a lot in your application. So just here, we're using the regular web client. We are already instrumenting that client to intercept the calls and record all the metrics that we can to get you those graphs. So by default, you won't get all the graphs of everything into Wavefront, because that would be a lot. But you do have all the metrics that are exported to the tool.
So let's actually try to fix that. And what we haven't told you is, in this example, we we do have two reverse lookup, actually. We have a free version and we have a paying version in this example. And in this case, let's say you don't really want to use the paying version unless you really have to, right? So if the free version works, then use that. If it starts like crashing, or it's not available, or it's too slow, then let's go to the paying version. And doing that with the RestTemplate in an imperative style can be quite hard, right? Because you emit a request, then you need to cancel the request and emit another request, making sure that the connection is handled properly. That can be quite messy. And what we want to show you is, once you have the infrastructure to use those reactive operator, how easy it can be, and you can abstract that complexity away. So what we want to do is we want to be able to configure a timeout. So whenever the request takes more than, let's say, I don't know, 50, 100 milliseconds, you want to say, okay, I give up and I'll switch to the paying version for this request. So we want to have the infrastructure to be able to create some configuration items, and you can do that with Spring Boot using configuration properties. So it's a POJO where you can define a configuration structure. So I have now a dashboard dot reverse lookup dot timeout, and you can see I'm using the duration API here, and half a second as the default value. So let's use that actually in the application. So I need to enable this. So this will turn dashboard properties into a bean that I can use anywhere. And let's actually use that in our service here. I'm going to say I want to keep that timeout around, and I just need the properties. There we go, I have it. So this is where we want to apply some operator, right? We want to say, if this is too costly, if it's too slow, then I want to do something else. And
so now we want to have something like, if it's longer than this duration, cancel the first one and fall back to the thing that I'm giving you. It might be a default value, it might be something else. So in our case, this is the timeout operator that does all of this. So if we exceed the given timeout, it will cancel the first request, close the connection and all that. And it will fall back to using the paying reverse lookup. So issuing another call, this time which will be way faster, but paying, but way faster. And it will return that as a response. So doing so with one operator is really nice, because trying to achieve that with imperative programming is much harder. You know, you'd have to deal with concurrent exceptions. You have to deal with threads and all that. It's not trivial. So in our case, because of the functional programming way of dealing with this, we can have that right now in our application.
All right, so let's have a look and see what happened there. This is faster, right? You've noticed this is really faster. So what's happening is the latency, the fake latency that we've added is still in play. But whenever, because 500 milliseconds is the default, whenever we hit the 500 millisecond window, we use the paying service. And we can actually see that in action in a graph. So it's very easy to build a graph where you see the usage of the free service, the usage of the paying service in the same graph, and try to resonate how much which is used based on basically on configuration. So let's do that. Let's create another chart. I'm going to unzoom a bit here. So what I'm going to do is I'm going to say that I want metrics again for the client, but this time I want the count. And I want to add a filter. So I want to say I'm only interested by the free service. And probably I also only want for, just so that we have a single graph, the ones that have succeeded. And count is basically something that will increase all the time. So it's not very easy to get a sense of how much it is used. So to do that, I can apply a function. I can add a rating. I can say, give me a rate every half minute. So let's change that to 10 minutes again. So this is the rate that I have. I'm going to run some traffic here so that we get fresh data. And then you can basically copy this and go that service. And then you can see what the usage of the costly service is way higher. So the orange line, sorry, is the free service, and the blue line is the costly service. And you can see that the costly service is used really, really a lot. But if we go here and we say dashboard reverse lookup timeout, let's use 4 seconds as a value. So we're not going to use the paying service as much because we are okay to wait up to 4 seconds. Then it will slow again, but not as slow as before.
So yeah, we're capping at 4 seconds. But basically in the previous graph, what you saw was the artificial 80%, 20% distribution that we set artificially in our remote service. That's basically what you have. You've got an 80-20 distribution with the calls. If you're setting a timeout on your end, that's quite low. If you're a bit willing to take some more latency, the distribution changes because we're not setting the 80-20% thing on the remote service is not like one slow call will go directly to 8 seconds. We're distributing in a normalized fashion the response times to make it a bit more realistic. So depending on how long you're willing to wait, you'll get a different distribution of paying versus free calls with your client. So that's basically what you'd expect. So it's a good thing to see that when we're changing the latency that we're willing to take and you're basically seeing that for real in your application, and you're also seeing that in your graph. So we're definitely measuring the right thing here.
So there is 10 minutes left. Do we show the custom metric or should we switch to QA? What do you think?
I think we've got quite a few questions. I'll try to answer a few of them, and maybe we can show the custom metrics.
Yes,
right after.
We have a lot of questions. Okay. Okay. We can start from the beginning. What do you think?
Yeah, there was one from Matt about RestTemplate having a nice exception. I'll try to read them. Oh, they're showing on the screen. Perfect.
RestTemplate has a nice exception hierarchy that been thrown when a non-200 response is received. Can you touch on what this look like in the context of using WebClient and .block function?
So if you're using .block, so when there's an error in a reactive application, it's flowing through the pipeline. So you're getting an error message in the pipeline. So there are two ways of dealing with that. Usually in a reactive pipeline, you are dealing with operators like timeout and others. So you can basically apply on error. There are a lot of things you can on error resume, which means you can go fall back to some other thing, on error return, so fall back to a default value, and so on and so on. There are a bunch of operators that are really defining a lot of things. If you are doing dot block, you're getting a different thing. So when you're going dot block, those error messages in the pipeline will be turned into proper exceptions. But it's, how should I say that? It's less trivial in that sense, because you'll have to deal with different exceptions. You might have a good exception hierarchy, just like RestTemplate, but with a functional model, using the operators is much easier, and it's easier to test. It's easier. It's more native to the programming model. So even if you're using dot block, you'll find that you'll be more and more using operators, because it's more natural. And usually, because these with reactive and the functional programming, there's always that sense of time passing with the timeout. So you're dealing with time. It's not something that you can really do with imperative programming. So you'll see that those operators that will help with that as well.
Okay. Here another question. Michael asks, what is the advantage of usage web client in Spring MVC app, and it also blocks web servers working thread?
I think there are several questions that are touching on that. One way to answer that, so if you're here, we have we have a serverless application, a blocking one with MVC with web client. So here we are still taking advantage of web client because we are parallelizing calls with mono zip. So we are doing a scatter gather thing, and we are doing things in a more concurrent manner. If you wanted to do that same thing with RestTemplate, you'd use the async RestTemplate, and you'd have to deal with completable feature types like this. But with those types, it's harder. You can't do timeouts. You can't do on error. It's really harder, especially when you're trying to compose them. So in this case, we're getting performance, and we're getting like fine-grained implementation. There are other questions related to that. I think I'll answer them right now. So questions about what's the advantage of using reactive and Webflux on the server side. In that case, it's good if you're dealing with latency. So there are two main cases for reactive, in my opinion, in Webflux in general. First one is not necessarily performance. It's really about latency. So if you're dealing with slow clients, or if you're dealing with scatter gather calls like this, or latency, it's really good at runtime for that. It's got really good properties. The other one is if you're dealing with concurrent programming, or if you have to do a lot of things like we're doing right now, even if latency is really good because everything is in the same data center, everything's perfect, good for you. But you're still getting mileage out of Webflux and reactive programming, because scatter gather and all of that is easier to deal with the functional model once you're a bit familiar with it. Those are the main two use cases.
Okay. We have also this question about web client also support WebSocket.
The answer is no. We have a separate client. We've got a WebSocket reactive client shipping with Webflux. So it's separate, but we have one.
Okay. Another one about microservices architecture. Do you prefer gRPC or RSocket in microservices architecture?
Yeah, that one, I'm definitely biased because I'm working on RSocket support.
Okay.
I'm not sure we have like a really great gRPC story right now in Framework or Spring Boot. I know that there are existing third-party starters with communities around them that do great stuff with gRPC. To me, RSocket feels more natural because it's built with reactive streams, like from top to bottom. And it's got really interesting properties because it's a high-level protocol. You can do a lot of things with it. You'll find on YouTube a bunch of talks that we've made on RSocket. If you're interested in it, I think RSocket is the way to go. We've got several products and projects working with RSocket, including Spring Cloud Gateway. So we're definitely building on the RSocket story and trying to introduce it wherever it fits in our story. But gRPC is fine if you're used to gRPC, and especially the RPC contract side of it. There's nothing wrong with it.
Okay, perfect. And we have also this one, or maybe we have an answer, no?
This one, when
what
you're
about
using
thread locus in such approach, are they will be automatically passed through reactive pipelines?
The answer is no. When you are dealing with a reactive application, bits of code can be executed on any worker thread at any time. So you got no guarantee about what's being executed and where. It's optimized for you. So we have instead a reactor context. So it's a context object that you get passed in the pipeline where you can store values, get values out of it. That's where we store like authentication stuff. That's where we store metrics related stuff. So yeah, transactions and all. So thread local is not the way to go. There are ways to somehow tie reactor context and thread local together, but it's really not efficient because you are basically blocking. As soon as you switch threads when you're executing your application, it's got to do work to copy things around. It's not really efficient. So if you can avoid it, please do avoid it.
Okay. And this question is related because how R2 DBC library can async a JDBC driver or Oracle PostgreSQL driver that use blocking API?
Actually, it does not async the JDBC driver. AutoDBC is really a separate spec from JDBC. JDBC being a blocking API, there is no way around it. If you want it to be truly reactive, you need, at its core, it needs to be reactive. And that's what AutoDBC does. So AutoDBC is a spec and a number of driver implementation, including Postgres, and Oracle recently announced an Oracle driver for AutoDBC. So when you use AutoDBC, you're still using SQL, of course, so it's still your main programming contract. But you're really using a different driver, and that's how it works in a reactive fashion.
Okay. Okay, and also another question about Tomcat. Tomcat major than 9 support reactor?
Yes.
Yes, perfect. Another question about batch. Is it also a good to use a reactive also for CPU intensive operation as a batch?
Where reactive shine, that's really where there is a latency involved and you have I/O. If it's like purely CPU, the advantage is not that high.
Yeah, unless the composition of the functional API is really important to you, then it could help with your programming. Otherwise, like Stéphane said, for runtime, if there's not really a lot of I/O in parallel or no latency, like Stéphane said, maybe not.
Okay. In this moment, I'm still using MVC for my RESTful services. Is production ready reactor? In the new services, I would like to write them using a reactor. So, is production ready?
So it is production ready since Spring Framework 5.0. Right now, we are in maintenance mode in Spring Framework 5.3. So we already had like 3 feature releases since the announcement of Reactor. And the team will start soon working on Spring Framework 6. So really, we're really entering a maintenance mode for this generation. So it's quite mature. I think rather the question should be, do you need it?
Mm-hmm.
Or your use case actually need that technology? If you're using Spring MVC and everything is working fine for you, you don't have any particular problem with MVC, just stick with it. It's not going anywhere.
Yeah, great point. As you actually don't use a back pressure in your, you can implement the very same logic with at async. What is the advantage of switching to half reactive style?
I think that question got asked when we were just gathering the things and not doing the timeout and not doing the fallback and so on. So that's true if you're using at async and you've got a bunch of completable features and you can assemble them somehow, and it kind of works. But in this case, in our case, with the we are not backed by an executor with like some kind of thread pool, which might be not optimal, especially when you have a lot of calls. In this case, in dealing with latency and so on. So in our case, it's better with runtime properties for latency, especially if you've got a lot of latency, slow clients. It will behave better than a thread pool. And second, as soon as you're dealing with the timeouts and fallbacks and more advanced use cases, you can't do that with async. You need something more. That's what we had.
Okay. When we will have the first version of Spring Native ready for production?
We're in beta now.
So it's an experimental project that you can use right now on Spring.io. You can try it out and give feedback to the team. The plan really, I was mentioning Spring Framework 6 and Spring Boot 3 that goes with it. The plan really is to merge that capability somehow in the core framework. So it's not going to be a separate project forever. It's a separate project now because we are spiking and experimenting and collecting feedback and improving things with the GradVM team at Oracle. But the plan is really to focus on integrating that in the framework proper, and that's the plan for Spring Framework 6. We're starting working on that. There is no hard deadline yet as when it's going to be GA.
When it's ready.
Okay. We have another question, quite similar from the previous. And is there any plan to support join R2DBC? Because we have another question. We had another comment related. I used that in a project, and I had to use array with a Postgre to simulate joins somehow with the trigger functions.
I have no idea.
I don't know.
But what could be an interesting suggestion for this one? Most Spring projects have a Gitter channel. So if you go to gitter.im, it's basically a chat room for a Gitter project. And I believe R2DBC has such a chat room. So you can just join there and ask a question, and the maintainers are usually online. So you could get your answer that way.
Yeah.
Okay. We didn't have other questions. Okay. So thanks for being here today. We are really happy to have such a great talk. And
cool.
Okay.
Maybe we want to show the slides with the URL to the actual code.
Yes.
Merci beaucoup. Merci beaucoup.
De rien.
Merci.
This is the link for the slides. Okay, you can post in chat if you want, so we can post it to YouTube.
We will.
Okay. Yeah.
Okay. Okay. Perfect. Thanks for being here. We will hear next month for another great talk about Spring, and of course, VMware, our main sponsor, help us to create these great talks and meetups. Thank you, everyone, and Stéphane and Brian. Really, thanks for your experience and your time. We receive some thanks from the audience. And,
Thank you very much.
Thank you. It's great.
bye. Bye.
Bye now.
Bye.